laksana dengan jitu, penuh bermisi guru ayu, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okay, salam sejahtera kepada semua guru, ibu bapa dan juga belajar-belajar sekalian. Okay, selamat datang ke Pusat Tuisyen Akademi YouTuber dengan usaha sama e-didik Malaysia dan Kelab Guru Malaysia. Okay, bermula bercuma, selamanya bercuma. Okay, mula-mula cikgu memperkenalkan diri dulu. Nama saya Cikgu Kok daripada SMK Tinggi Sandawi Melaka selaku moderator pada petang ni. Okay, kami juga akan bersiaran langsung daripada channel Mr. P. Siapa yang masih belum subscribe, silalah tekan butang subscribe sebagai tanda sokongan kepada Mr. P. Okay, Mr. P hari ini dia selaku presenter. Okay, biar saya memperkenalkan Mr. P dulu. Rasa banyak-banyak belajar sudah tahu siapa Mr. P lah. Okay, Mr. P ialah dari Kolej Tingkatan 6 Tun Fatimah Melaka, satu kampung dengan saya. Okey, selaku presenter hari ini, so belajar kena beri perhatian apa yang cikgu akan mengajar hari ini. Okey, turut berada di konting kami ada Cikgu Nur Izian binti Saleh. Ini pun pelajar pun kena dia lah kerana banyak kali cikgu juga sebagai presenter pada hari Jumaat. Okey, cikgu ini adalah daripada SMK Teluk Panlima, Garang Selangor, selaku control host pada petang ini. Okey, kita akan mempelajarkan tajuk hari ini adalah fizik tingkatan 5, quantum fizik 7.2, iaitu Photoelectric Effect dalam dua bahasa. Okey, kelas ini akan berlangsung lebih kurang 1 jam. Okey, sebelum kita nak teruskan kelas ni, cikgu ingatkan semua pelajar dan juga penonton yang ingin menghantar komen sila gunakan bahasa yang sopan dan juga gambar profil yang bersesuaian untuk tontonan umum. Okay, link sijil akan diberikan hujung siaran ni. Link e-sijil hanya dapat diisi dengan menggunakan email e-didik, MOEDL mail, email MyGuru dan juga email Javi. Okay, so sila fokuskan kepada isi pelajaran yang disampaikan oleh Mr. P nanti. Semoga kelas kita pada petang ini dapat dimanfaatkan sepenuhnya oleh para pelajar. Okey, dengan jangan buang masa, saya serahkan kelas ni kepada Mr. P. Dipersilakan Mr. P.
Okey, so terima kasih Cikgu Kok selaku moderator dan juga bersama saya petang ini ada Cikgu Izian, okey, selaku control host. So terima kasih kepada cikgu-cikgu yang teman saya pada petang ini. Okey, so saya Mr. P kini mengajar di Kolej Tingkatan 6 Tun Fatimah Melaka. Dan minggu ini kita hanya ada kelas tingkatan 5, iaitu hari ini seperti biasalah pukul 2 petang. So kelas untuk tingkatan 4 akan disambung balik pada next week, setiap hari Jumaat 9.30 malam dan kini mereka sudah sampai subtitle 5.4 pembiasan gelombang. Okay, so I will continue for our last chapter. Okay, so our last chapter for Form 5 will be quantum physics, and I will continue for the subtopic 7.2, which is regarding photoelectric effect. So today's subtopic 7.2 will be have about 2 learning standards. For the first learning standard, you need to able to explain the photoelectric effect. So let us see what is the meanings of the photoelectric effect. So photoelectric effect is the emission of photoelectron from the metal surface when light at the certain frequency illuminated the metal. So you can look at the figure here. So the the metal consists of many atoms. Okay, will be look at the figure will be like this lah. Okay, so there will be have a lot of the free electron moving around the atom. Okay, atom of the metal. Okay, then when the light or called the photon emitted, okay, to the metal surface. Okay, so that means there is an energy transfer from the photon or light to the metal surface. And you can see that the photoelectron, or commonly we know as the electron, will be emitted from the metal surface. Okay, so this phenomenon we know as the is photoelectric effect lah. So this phenomenon. So here, this is the arrangement of the circuit by using photocell to show the photoelectric effect. So the first here, this is a metal surface and will be connected to terminal negative of battery. So we know as also the cathode. So emission of the electron from a metal surface when it is illuminated by the electromagnetic wave. So the electromagnetic wave here referring to the photon of the light. Okay. So, and then we have the second part here will be the detector. So the detector is also connected to the positive terminal battery. So we know as the anode also lah for the detector. So the function for the anode here is to collect and receive electron beam from the cathode. So here we have the light or photon. So electromagnetic wave, or also known as the light here lah. So with energy which is equal to E equal to HF. So this one last subtopic Cikgu has stated already taught last week. Okay, so this formula you should be able to understand already. So directed to the cathode. So the cathode will be metal surface here to excite electron from the surface. So that means firstly, as just now I mentioned the meanings of photoelectricity. So the firstly, the photon or light will be directed to the metal surface with a certain frequency. Okay, and if I say the frequency of the electromagnetic wave is more than the threshold frequency of the metal surface, so the electron will be emitted. Okay, so the electron is negative charged, so will be directed to the anode, which is in positive terminal here. Okay, so because of the flow of the electron, so the ammeter here will be deflected. So the function of the ammeter will be measure the photoelectric current in the circuit. So you will see there is a deflection of the pointer of ammeter showing that the electron is flowing, and then the current will be flow. And the last here will be the parts will be the vacuum tube here. So be here. So the vacuum tube should be vacuumed to prevent any interruption on electron when moving from cathode to anode. So this will be the 5 important component for the photocell, which able to show the photoelectric effect. Okay, so now we go to the working principle of the photocell to showing the photoelectric effect. So the firstly, the target metal surface illuminated with the monochromatic light will emit electron from the metal surface, which is at the cathode. This emitted electron is also known as the photoelectron. So as mentioned just now, the electromagnetic wave here will be the light, or we know as a photon. So the monochromatic light here will be referring to the one color of light only. Maybe it will be red color or others color. So second, the emitted photoelectron is attracted to the anode to produce a current. So as I mentioned just now, the monochromatic light here must have the frequency which is greater than the threshold frequency of the metal surface here, so that the energy will be able to escape from the surface of metal and then will be directed to the anode direction here. And then will be causing the flow of electron in the circuit, and the current will be produced, and the pointer of the emitter will be deflected lah. So be here. So the emitter measures the photoelectric current detected when the potential difference between the electrode charges changes here. Okay, so the potential difference will be at these two parts lah. Okay, then the next will be kinetic energy and the work done by the potential difference in the photoelectric effect here. So firstly, you can see when the electron is emitted from the metal surface, they will be moving at certain speed. So, and the energy contents for the electron here will be the kinetic energy, with the formula will be 1/2 mv squared. So the m will be mass of the electron, and then v will be speed of the electron released from the surface here. And then the second, the work done by the potential difference to the acceleration electron from cathode to anode will be with formula EV. So, and the work done by the potential difference here can be also known as a stopping voltage. So the electron released from the surface of the cathode have the kinetic energy that is equivalent to the work done by the potential difference to accelerate the electron from cathode to anode. So that means to enable the electron moving at certain speed, so we need to have potential difference provided for the electron moving from cathode to anode. And the relationship between the kinetic energy and the stopping voltage here will be 1/2 mv squared equal to EV. So the V will be equivalent to the speed of the electron. V will be the potential difference of the power supply here, and the mass will be the mass of the electron, which is the value 9.1 times 10 power negative 31 kg. So this value will be fixed. And then the charge of the electron will be represented as smaller e with the value of 1.6 times 10 power negative 19 coulomb here. So based on the experiment, the photoelectric effect depends on two characteristics. So the firstly, depending on the light intensity. And then the second will be depends on the light frequency or the wavelength of the light. So let's discuss detail for the effect of the light intensity on the emission of the electron from the metal surface here. Okay, so firstly, the emission of the electron beam or photoelectric current is directly proportional to the intensity of the beam. So you can look at the graph here lah. So photoelectric current against the intensity here. Okay, so you also can observe the figure here. When the light is with low intensity, there will be have few of the electron will be emitted from the surface of metal here. However, when we increase the light intensity, so the numbers of electron will be emitted on the surface of metal will be increased, and the electron emitted will have the same kinetic energy. So that means that for the light intensity, there is actually only able to increase the numbers of electron emitted from the metal surface, but the kinetic energy of the electron will remain the same. Okay, so the kinetic energy of the emitted electron does not depend on the intensity of the beam. Okay, so this is effect of the light intensity to the character of the electron here. So the next will be regarding the light frequency or the wavelength of the light. The higher the frequency, that means that the wavelength of the light or photon here will be shorter. So as we already know that the frequency and the wavelength is actually inversely proportional, the relationship between F and the lambda here. So the higher frequency or shorter wavelength of the photon of light, the higher the kinetic energy of the photoelectron emitted from the metal surface. So as I mentioned just now, the relationship between the frequency and the wavelength will be inversely proportional. So from here, you can very clearly see that the wavelength higher, so the frequency will be shorter. Okay, so from the figure, you can see the wavelength of the green light here is actually longer. You can actually observe the crest of the wave here, okay, between two consecutive crests. And then here will be the wavelength for the blue color light here. So from here, you can see the wavelength for the blue light will be shorter compared to the green light. Okay, so that means that the frequency belong to the blue light will be higher. And from here, you can see also the speed of the electron emitted from the metal surface for the blue light here will be higher compared to the green line here. Okay, so that means the frequency of the photon is actually directly proportional to the kinetic energy. Then the wavelength will be inversely proportional to the kinetic energy of the electron released from the metal surface here. Okay, so here we want to discuss about the threshold frequency. Okay, so what is the threshold frequency? So the threshold frequency definition here is the minimum frequency of light needed to emit electron. So from the figure here, you can see there is no ejection of the electron from metal surface for this figure. I mentioned here is A. And then you can see the photon directed to the metal surface for figure B here causes the photoelectron emitted from the surface. Okay, so this is actually related to the frequency of the electromagnetic wave or the photon which is directed to the metal surface here. So that means that from the figure A, so the frequency of the photon directed to the metal surface here is actually lower than the threshold frequency. Okay, because the threshold frequency mentioned here is the minimum frequency needed for the light to make the electron emitted from the metal surface. So here, low frequency light does not eject electron. So as I mentioned, the frequency of the electromagnetic wave here, the yellow color light here will be lower than the threshold frequency of the metal here. While for the purple color light here, so showing that the high frequency light able to eject the electron from the metal surface. So the frequency belong to the photon here for figure B will be greater than the threshold frequency. So the second terms you need to understand is the threshold wavelength. So the maximum wavelength of the light needed for a metal to emit electron. So as I mentioned just now, the frequency and the wavelength, the relationship will be the inversely proportional. So as the frequency of the photon in figure A is low, so that means the wavelength will be longer lah. So as the wavelength is longer than the threshold wavelength, so the electron also unable to eject from the surface of the metal. So on the other hand, for the figure B, the wavelength for the photon will be shorter, which is shorter than the threshold wavelength, and the photoelectron will be able to emitted from the surface. And then another terms here you need to understand is the work function. So work function is defined as the minimum energy needed for photoelectron to be emitted from a metal surface. So here at the figure A, the work function from the electromagnetic wave here will be higher lah. So the energy, photon energy from the photon here is actually less than the work function of the metal surface here. So the electron will be not able to release lah from the metal surface. So while the photon energy from the photon here is greater than the work function of metal surface and able to release the energy, the photoelectron from the surface of metal. So the relationship between the photon energy, E, work function W, and kinetic energy will be like this lah, huh? E equal to W plus KE lah. And then the next, we want to determine the value of the Planck constant by using the Planck constant kits here. So the experiment I'm going to discuss here is to determine the value of Planck constant using the Planck constant kits. So the figure here showing the Planck constant kits lah for this one. So it's connected to the voltmeter. So the voltmeter will be here lah. And then we have the connecting wire also lah for the experiment here. Okay, so the procedure for this experiment, firstly, the Planck constant kits as in figure is used to determine the value of Planck constant. The voltage is adjusted until the LED 430 nanometers start to light up. So will be blue color light here lah. Okay, so you have to switch, have to adjust to 430 nanometer here, referring to the blue color light. And then the button, this button have to adjust it, okay, to ensure that the blue light here is light up. And then you have to record the value here. So the value actually is indicated as the voltage activation. So the voltage is known as the activation voltage, the minimum voltage required for current to flow in the LED. So we need to record the value here. Okay, firstly, we need to adjust our switch to blue light here, and then we need to adjust this button, potentiometer here, and when the blue light is light up, you have to record the value here, which is known as the activation voltage lah. Then second, the activity was repeated for the 505 nanometer, which is actually the green color light here lah. And then the next will be the 560 nanometer, 650 nanometer, and the last one will be 655 nanometer. So it will be different light. So as we know, for the visible light region, the red color light will have the longest wavelength, and then the violet light will be the shortest. So voltage respectively recorded. So the voltage referring to the reading of the voltmeter here. So all results are scheduled. The frequency of the LED is calculated. So you have to calculate frequency. And in each case, the energy of the emitted photon EV is also calculated. So that means you need to calculate these two values, frequency and also the EV here. Okay, so number 3, a graph of the photon energy EV against the frequency of the emitted light is plotted. The Planck constant is determined from the gradients of the graph. Okay, so this is the manipulated variable. So the 430 nanometer referring to the blue light. And the first value here, you can calculate by using the formula here. Okay, so from here, 3 times 10 power 8 will be the speed of the light. And then the wavelength referring to the blue color light wavelength, which is 430 nanometer. Okay, then you get the value will be this. Then the next here, the voltage start to light up the LED, which is referring to the activation voltage. So where you get from the reading of voltmeter. So the first you get, this is just a reference reading, 2.75. Okay, and then next you have to calculate the photon energy released here. So it will be equal to EV. So E will be the charge of the electron, which is equal to 1.6 times 10 power negative 19 multiplied with V here. So you get this value 4.40 times 10 power negative 19. And then the others value, you will also calculate and measure by voltmeter, and then calculate again for E also. So you will get this data in this table. And then next step, you have to plot the graph. Okay, so the reading we have already calculate, okay, will be like this. So the question asks us to plot the graph E against the frequency. Okay, so E will be referring to this. And then frequency referring to this reading. So we plot first reading. Here will be 6.98 is about 7. Okay, for the frequency. Okay, and then the E reading here will be 4.40. So will be here. So this will be the first point. The second point, also the same will be here. And third, fourth, and fifth here. And then you have to draw a baseline. So you get the graph will be like this. Okay, so and then the gradients will be, we pick the big triangle. So we can get the gradients more accurately. Okay, so as mentioned just now, the Planck constant will be the gradients of the graph. So it will be here. E will be here. Against F will be here. Okay, so we get the reading here. This point will be 6.8 and then 4.2. So another point I pick here will be 0.0 here. So after calculate, we get this value, which is quite closest to the value of H, 6.34 times 10 power negative 34. Okay, so the next will be discussion. Okay, so the energy of light, energy of photon emitted is given as E equal to HF. So the H will be the Planck constant, and then the F will be the frequency of the photon or the light here. So here. Okay, so here will be the photon, here will be the photon. And then the second, if the V is the voltage applying across the LED as it begins to emit light, so the V referring to the activation voltage lah. The energy supply to the electron is given as E equal to EV. Okay, and then the expression of EV equal to HF is linear equation. So when a graph of the EV against F is plotted, a straight line through the origin is obtained. So the gradients of the graph is given as a value of H. So just now we plot already lah. So actually it's from here. E equal to HF is the photon energy. And then the second here is E equal to EV. So we get this relationship, and the EV is referring to E lah in our graph here. So E against F, so that means the gradients will be H, which is passed through the origin. Okay, so we have already completed our learning standard 1. So let us do some exercise. For the question 1 is actually from the SPM 2021 question number 2. So diagram 2 shows an apparatus to study the effect of the photoelectric for zinc metal. So here, the cathode here will be the zinc metal. The electrons are emitted from the surface of the zinc metal. So when the light is directed to the metal, zinc metal, so the electron will be emitted and move towards the anode here. The light frequency used will be this value F. That is as this the threshold frequency. So here that means that they will have the electron emitted because the frequency of the light is greater than the threshold frequency, which is the minimum frequency required for the electron emitted from the metal surface. So the first question asks you to define the threshold frequency. So as I mentioned, there will be the minimum frequency that can produce photoelectric effect at the metal. Okay. Okay, so the next will be B. So calculate the work function W of the zinc, of the metal zinc, given work function. Okay, so the question already give you the formula also lah. Okay, so you just need to substitute all the value given here. So the H will be equal to 6.63. Okay, and the question given also the threshold frequency already, which is equal to 9 times 10 power 14. So you just substitute all the value, then you get 5.94 times 10 power negative 19 joule. So 2 marks. First mark will be given for the correct substitution. Second mark will be given for the correct answer with 2 decimal places and correct unit. Okay, so you need to give 2 decimal place minimum and correct unit here, joule. Okay, so the next will be the intensity of light that strikes the surface of zinc metal does not affect the kinetic energy. Okay, so just now we know already, I explained already, the intensity will be affecting the numbers of electrons emitted from the metal surface. Okay, but the electron release will have the same kinetic energy, although your intensity of light is increased. Okay, so the kinetic energy of the electron will be only depends on the frequency of the photon light. So here 2 marks. Firstly, you have to give that the light intensity will affect the numbers of electron released from the metal surface. And the second, the kinetic energy of the electron will be only affected by the frequency of light. So here will be the 2 marks, which is related to the theory just now I explained already. Okay, so question number 2 will be the calculation question. So a quantum of the light with the energy 3.5 times 10 power 19 joule fall on the cathode of the photograph. So current flowing through the cell is reduced to 0 by reversing the potential, which cathode is at positive potential of 0.25 volt relative to anode. The minimum energy needed to release the electron from the cathode is how many here? Okay, so to understand this, so just now we already know that for the correct connection, so the anode will be connect to the positive terminal of battery, and then the negative will be connecting to the negative. And here, when there is a reversing potential, so that means the terminal here positive will be negative already lah. So that means we change the terminal of the battery here. Okay, and cause the electron will be stop moving because the electron will be with the negative charge, and now the forward terminal here will be also negative already. Okay, so that means that the minimum energy here you can calculate by using EV lah. Okay, so this is the formula which I introduced just now. So the KE will be changed to EV here. Okay, and then we need to have the minimum energy, so we rearrange it again. So we want to get the W here. So E will be equal to E will be minus with EV. So the question given us the photon energy here is equal to 3.5 times 10 power negative 19 will be this. And then the E, the value will be fixed, and the voltage causes the electron to stop will be 0.25. So we substitute all the value, then you get your answer will be 3.1 times 10 power negative 19 joule. Okay. Then for the next question 3, question number 3. So determine the recognition voltage required to stop the fastest photoelectron released from the nickel surface if the ultraviolet light with the wavelength 220 nanometer is shine on it, and the work function for the nickel will be 5.01 EV. And here the question given you the value of HC. Okay, so we just use the value given lah. Okay, so here the question also asking the same, almost same the question lah. So will be also regarding the stopping voltage here. So that means the kinetic energy will be also the EV lah. So the V here will be referring to the activation energy, activation voltage. And also the same, we apply the same formula. Okay, just we convert the KE become EV here. Okay, so which actually we need to find out lah. And then the E, the value is not given, but we can calculate by using this formula. This formula you already learned at the subtopic 7.1 together with Cikgu Hasnita already. Okay, so with this, the question already give what is the value for HC. And then for the value HC here, and you can see the answer is in EV. So the wavelength here will be maintained for in the unit of nanometer lah. Okay, so we just substitute the value given, and then here 220 is given also lah, and then we minus 5.01. So we get our value, our answer here will be 0.64. Okay, so the answer here will be B lah. Okay. Okay, so Cikgu Kok, I think we can take a break.
mic Cikgu Kok.
Okey, belajar jangan pergi mana-mana. Selepas ni kami iklan, lepas tu Mr. P akan kembalilah bersama kami dengan chapter 7.2 ni. Okey?
So high I'm hypnotized. What's up is down, what's left is right. Chasing stars and holding you. I can't see the end, but we'll see it through. Times don't fly too high. Be sure to keep the ground in sight. Fly forever if you keep it tight. Love the world but keep the sky on your mind.
Okey, baiklah. Jom kita teruskan bersama dengan Mr. P. Dipersilakan Cikgu.
Okay, so thank you, Pangkok. So now let us continue to our second learning standard, which is identified 4 characteristics of the photoelectric effect that cannot be explained by using wave theory. Okay, so actually this part is a summarize of subtopic 7.2 here. Okay, so the 4 characteristics of the photoelectric effect. So the first, as I mentioned just now, the higher the frequency, the shorter the wavelength, the greater the kinetic energy of the photoelectron emitted from the metal surface. So here, the green color light will have the lower frequency, and it will have the lower kinetic energy, and the electron emitted from the metal surface will be moving in lower speed compared to the blue color light here. So which will have a higher frequency and will have the higher kinetic energy, so that the electron emitted will have higher speed. And then the second, the electron cannot be emitted from the metal surface unless the frequency of the light wave is greater than the critical value, which is known as the threshold frequency. Okay, so here this is some of the example of the threshold frequency of the different metal surface here. So for example, the potassium here, the threshold frequency will be 5.56 times 10 power 14. And the threshold wavelength will be 540. So that means that the wavelength, okay, you can see the wavelength. Okay, so the wavelength for the electromagnetic wave here or the photon must be lower than this value, so that the electron will be able to gain enough energy to release from the metal surface. So here we have the example of the red light here, so which the wavelength will be between 620 to 750 nanometer. So you like say the metal we choose here is the potassium. So the wavelength for the red light here is actually more than the threshold wavelength here already, which is 540 here. And you can also mention that the frequency of the red light here will be less than the threshold frequency for potassium metal here. So for the sodium, the wavelength for the red light is also considered higher a bit lah, is at the boundary range lah. Okay, so that the red light will be unable to let the electron from the metal surface gain enough energy to release from the metal surface. Okay, so it's actually the theory is very simple lah. So the electron is actually attracted by the nucleus of the atom. Okay, so they will be not easily to release from the metal surface. So to release from the metal surface, the photon energy must be higher. Okay, so that the electron will be able to overcome the attraction in the nucleus of the metal. Okay, so here the electron will be not able to emitted because the frequency of the red light here is less than the threshold frequency of the metal. On the other hand, you can mention also the wavelength of the red light, okay, is greater than the threshold wavelength of the metal surface here. Okay, so the third characteristic, okay, which is unable to explain, okay, or observe in the wave theory lah. So the third one will be the kinetic energy of the photon electron does not depends on the intensity of light. So the increasing of the intensity of light does not increase the kinetic energy of the photoelectron. So this figure just now I also explained already lah. So if the intensity of the light is smaller or lower, so the electron emitted will be less. When you increase the light intensity, so the numbers of electrons will be increased, but the kinetic energy belong to the electron will be still maintain the same. Okay, so this will be also unable to explain by the wave theory. Okay, because the wave theory mentioned that the light of any frequency will cause the electron to be emitted. So for explanation just now, the frequency must be at least greater than the threshold frequency. Okay, and then the last character here will be referring to the photoelectron emitted from the surface instantaneous, so it will be immediately, okay, even at the low intensity of light. Okay, so you can look at the GIF here. So the emission of the electron from the metal surface by photoelectric effect is instantaneous. So that means there is no time lag between the incidence of the photon. So we here, incidence of the photon to the emission of the photoelectron here. So there will be no any time lag here. Okay, so here if you compare to our another emission of electron by using the thermionic emission here. So the thermionic emission, the electron released from the surface of matter is actually need to take some time. Okay, so this one you can recall back the subtopic 5.3. So thermionic emission is the emission of the electron from the metal surface when the heat is emitted, when the heat is applied for the metal surface. Okay, so these two theories is quite similar, okay, but actually it's quite different. Okay, so the thermionic emission, the electron emitted from the metal surface due to the heat provided, while for the photoelectric effect, so the electron emitted from the metal surface is due to the energy transfer from the photon to the electron in the metal itself. Okay. Okay, so we go to our question number 4. So we have left another 2 questions. So question number 4. The following photoelectric effect can only be explained by assuming that light is made up of the particles. Okay, except which one? The A, there is no time lag between the incident of the radiation and ejection of the electron. So this one is correct. Just like I mentioned already, there will be no time lag between the incident of the photon and emission of the electron. And then the B, increased frequency of the radiation will increase the kinetic energy. Okay, so this one also correct, right? Okay. Then the third, increase of intensity of light will increase the kinetic energy. So this one's supposed wrong already. So and then the D, light at the high frequency above the threshold frequency can cause the electron to come out of the metal. So this one is correct. So the answer will be C because the intensity increase will be not affecting the kinetic energy belong to the electron. So they will be still the same because the kinetic energy will be increased when the frequency of the photon increase here. So the answer will be C. Okay. Okay, so this is last question, section C. Okay, 20 mark question here. Section B is actually is a decision making question. Okay, so diagram 1.1 and 1.2 shows the behavior of the electron when green light and the blue light are propagated to the same metal. The incident is result of the phenomenon. Okay, so name the phenomenon that have occurred. So I think this will be quite straightforward, will be photoelectric effect. So you can see here we have the photon strike to the surface of the metal and causing the photoelectron or electron okay, emitted from the metal surface. So this will be first mark. Okay, and then the second will be the conception question, comparison between two diagrams given here. Okay, so based on the diagram 1.1 and 1.2 will be here. So compare the wavelength of green light and the blue light. So the wavelength can be able to compare by the length between two consecutive crests here. Okay, and then next will be here. So we are very clear that the wavelength for the green light will be greater than the blue light. Okay, so the wavelength of green light is greater than the blue light. And then the second, the question asks us to compare the frequency. So the frequency, this one you need to know the theory. The frequency is inversely proportional to the wavelength. Okay, so that means the frequency for the green light will be less than the blue light. Okay, frequency, green light, less than the blue light. Okay, and then the next, compare the speed of the electron being released from the metal surface. Okay, so if I say you observe the figure, you can compare the length of the distance now, the distance from the surface of metal to electron now. So you can see from the diagram, 1.2 is actually the electron released with higher speed compared to 1.1. But theoretical, we also know already when the frequency increase, that means the energy provided will be increased. So definitely the electron emitted will be moving with higher speed since the energy provided is higher with the higher frequency electromagnetic wave. So here, the speed of the electron release in the diagram 1.1 is less than 1.2. Okay, so C, based on the answer in B, set the relationship between the frequency and the wavelength and deduce the relationship between the frequency together with the velocity of the electron released from the metal surface. Okay, so you have to give two answers here, okay, which I boxed in red. Here we have 2 marks, so that means you need to give 2 points. Okay, so first, we already know the relationship between the wavelength and the frequency will be inversely proportional. So the first mark, the wavelength of the light decreases, then the frequency of the light will be increases. Or you can give the vice versa answer also, no problem. Then the second mark will be the frequency increase, the velocity of the electron released from metal increase, so it's directly proportional. Okay, so as I mentioned already, when the frequency increase, so that means the energy provide to the electron increase. So the electron will have a higher kinetic energy. Okay, so the next will be the 4 marks explanation question here. So explain how the working function of a metal and the threshold frequency of the incident light will affect the phenomenon named in A. So the question actually no any figure, just let you imagine here. So 4 marks. So 2 important terms you need to involve in your answer. The first will be the working function and then the threshold frequency. So as I mentioned just now, the working function will be the minimum energy needed to release the electron from the metal surface. And then the threshold frequency will be the minimum frequency of the photon to allow, to transfer the energy to electron emitted from the metal surface. Okay, so the first mark is a definition for working function here. Minimum energy required to release electron from metal surface known as a work function. This energy is needed to overcome the attraction between the electron and the atom in the metal. Okay, so third mark will be the definition for the threshold frequency. The minimum frequency for the light to release electron on the metal surface known as a threshold frequency. And if the frequency of the light exceeds the threshold frequency, hence the photoelectric effect can be observed. Or you can just give that the photoelectron will be emitted from the metal surface. Okay, so we go to the last 10 mark question, decision making question here. So diagram 1.3, so with this diagram, show a fully powered international space station, which range of solar board. So the solar board is here. So you are required to study the characteristic of 4 different types of solar cell in the table 1 below. So we this table. So we know that we are unable to provide any energy, for the at the outer space. So that means that here maybe this is a satellite. So they will need energy. So the energy can be provided from the sun. Okay, so the sun is actually the visible light, got also UV ray and others also. So that means there will be a wide range of the wavelength for the sunlight. Okay, so how the sunlight able to change providing the solar energy, and the solar cell will be converting the solar energy to electrical energy here. So this is actually what is actually the solar panel converting the solar energy to electrical energy. Okay, so here we need to choose which will be the best solar cell, PQRS, according to these 4 different characteristics. Okay, so the first, the minimum energy required to release electron from the atom in the solar cell. So this is a working function. So definitely we have to choose the material or the metal surface which will have a lower working function. If the working function is lower, so that means we only need minimum or less energy to enable the electron released from the metal surface. Okay, so here we are quite clear that we'll choose the lower working function. And then the second, the wavelength range that allow the solar cell to generate the electric current. So you can see here, so we have power -7, power 6, then here -7 for QRS. So that means the wavelength range will be wider for P. So if the solar panel able to converting the current with wider range of the electromagnetic wave, so that means with shorter wavelength or longer wavelength, so they will be also able to generate electric current. Okay, so here we will choose the wider range. Okay, so that means even the color is light, red light reach the surface, so it's still able to releasing the electron. Okay, so that means it's actually quite relating to the threshold frequency of the metal surface itself. Okay, so we will choose, okay, just now I mentioned already, lower working function so that the electron will be easy to emitted, and then the range will choose wider, okay, so that the percentage of the current converting will be higher. And then the next will be the reflecting ability of the upper surface of the protection layer. Okay, so there will be a protection layer on the surface of the solar cell. So we will choose the reflective ability will be shorter. So that means when the light go to the surface of the solar surface, so the light is able to absorb and not reflected. So that means we will choose the low. So that will be less light to reflected. And then the last will be the temperature range will allow high efficiency in the production of the electric current. So for sure, we will choose the wider range because the weather at the outer space will be have the very extreme range because they do not have any atmospheres. Okay, so that means the temperature might be very high or very low. Okay, so we need to choose the wider. Okay, so that able to exposure or functioning under the high temperature or low temperature condition. Okay, so we will choose actually P here. Okay, so as per advice, we will always do your answer in table. So firstly, so as mentioned just now, the minimum energy required to release electron from atom must be small. Okay, so that the electron can be released easily. And the second, the range of the wavelength must be large or wider. Okay, so that the percentage of solar energy to be converted to electricity is higher. And then the upper surface refractive ability must be low. So the numbers of photons reflected by the top surface of the layer can be reduced. Okay, and the temperature range that allow the production of the electricity at higher efficiency, so must be more higher the range, so that the solar panel can be functioned, right? Just like I mentioned. So the solar panel are exposed to high temperature in space, so will be able to withstand high temperature. So we choose P, and then the last mark here, you have to copy these four answer, these four aspects at the last part here. So you'll get the full marks in this section. Okay. So that's all for my discussion and sharing for subtopic 7.2. Okay. Okay, so thank you. I pass back to moderator, Bangkok.
Okey, terima kasih daripada Mr. P. Okey, tahniah dan terima kasih diucapkan kepada semua yang setia mengikut kelas petang ini. Okey, sebelum kita nak tamatkan sesi siaran langsung hari ini, mohon semua penonton tutupkan luangan chat, klik butang subscribe dan aktifkan ikon loceng supaya kamu tidak akan terlepas dengan sesi kelas Mr. P yang seterusnya. Okey, sila klik like dan juga share link kelas hari ini kepada rakan-rakan di medium sosial anda. Jangan lupa ikuti kelas-kelas fizik seterusnya yang pada hari Jumaat 9.30 untuk tingkatan 4 dan juga Ahad yang untuk pukul 2 seperti hari ini. Okey, layani kami punya portal www.academyyoutuber.com untuk mendapat info terkini berkaitan kelas tuition PERCUMA AYU. Dan juga kongsikan kepada rakan-rakan dan di guru-guru di seluruh Malaysia. Okey, link CJ kami akan bagi kepada belajar serta juga username Mr. P. Okey, so belajar boleh dapat daripada ruang chat hari ini. Okey, sila ambil perhatian. Link tersebut akan tamat dalam tempoh 30 minit sahaja selepas live ni. Okey, pastikan anda login hanya gunakan email e-didik, email MOE, email MyGuru dan juga email Jawi untuk membuka link perkenaan. Okey, sebelum kami nak tamatkan kelas pada petang ini, saya mempersilakan Mr. P untuk memberi sepatah dua kata kepada para pelajar. Okey, tempukan.
Okay, so thank you Cikgu Kok. Okay, so saya rasa subtopik 7.2 sebenarnya tak sesusah 7.3 dan 7.1 lah. So chapter ni sebenarnya pun tak sesusah yang kita expected lah. Okay, so rasa boleh simplify dan fahamkan. Okay, so saya punya nota untuk murid-murid nanti saya akan upload lah. Okay, so sila download kemudian. Okay, thank you.
Okay, terima kasih Mr. P. Cikgu Izian, ada apa nak kongsi dengan belajar?
Okey, Assalamualaikum warahmatullahi wabarakatuh. Cikgu nak ucapkan terima kasih kepada semua yang menyokong Akademi YouTuber dan selamat menjawab peperiksaan bagi tingkatan 5 yang masih belum jawab kelas paper fizik untuk trial. Buat yang terbaik dan gunakanlah video-video daripada cikgu-cikgu panitia fizik Akademi YouTuber. Itu saja. Terima kasih.
Okey, terima kasih Cikgu Izian. So belajar penting sila rujuk semula apa-apa yang cikgu share dalam Akademik YouTuber. Itu memang banyak menolongkan anda supaya anda boleh mencapai keputusan yang cemerlang dalam percubaan dan juga SPM yang akan datang. Okey, so kami semua ucapkan terima kasih kepada semua penonton Akademik YouTuber. Sekian daripada kami, salam hormat dan jumpa lagi. Bye.
Semua sekolah ditutup hingga cuti akhir tahun 17 Disember 2020. Anda tak cukup bahan? Tak ada rujukan? Tak faham? Anda nak tuition tapi PKP? Jangan risau, kami di Akademi YouTuber dengan kerjasama Kelab Guru Malaysia dan e-didik Malaysia mengadakan kelas tuition online. Semua peringkat ada, semuanya secara percuma. Video PDPC pun ada. Apa ditunggu lagi? Layari www.academyyoutuber.com. Dibawakan kepada anda oleh Akademi YouTuber.